Hey there guys, it's Lee here. Welcome to iMineBlocks. In today's video, I'm going to show you how to mine a brand new project. But this one's a little bit different because we're going to be using our hard drives to mine rather than CPUs and GPUs. So this is a project that I'm quite excited about. Originally, it was talked about in 2017 and it kind of got a little bit forgotten about. And then recently it's kind of just basically appeared and sprung up on us, and now it's basically released, ready to go, and we can mine it. So the project is called Chia, C-H-I-A, and it was developed by a guy called Bram Cohen, who you might remember created BitTorrent. So the developers is quite a strong team and they know what they're doing. So I think this is why this is going to be an interesting project. It's got very similar concept to Burstcoin, which, as you guys know, I was quite a big fan of back in the day, and a lot of you guys sort of mined that along with me, and we had mixed results with that one depending on exactly when you got in and got out of it. So this is a very similar project to that, and that's what we're going to be digging into today. So without further delay, let's get into it. So we'll just start up opening our web browser, and we're going to visit the main site. So it's chia.net. From here you can download the main program itself. So the good thing about this is that it's kind of like all-in-one user interface, whereas with Burstcoin you had lots of separate components and it got a little bit tricky to work with. But the good thing about Chia is it's all-in-one single interface, and it doesn't matter whether you're using it for Windows, Mac OS or Linux. You'll have a similar experience over each one of those. Now, just before we jump into this, I have heard reports that the Mac and Linux versions are slightly faster in terms of plotting, but for simplicity we're going to stick with the Windows version, and I'll probably do an update on the other versions in the near future. So mainnet was launched on March 19th, so we're roughly about 10 days behind the launch. However, still relatively early, so you're not going to be at much of a disadvantage compared to everyone else. So first thing we need to do is download the Windows version, which is actually version 1.01 for Windows. Okay, that's downloaded. I'm just going to run the executable from exactly where it is. Okay, so the main Chia blockchain wallet is up and running. So this is going to be the main interface that you're going to be using for the various components of it. So you'll use this for creating your wallet, interacting with your wallet, so you're sending and receiving. You'll also use it for plotting and also use it for farming or mining. So it's quite cool as an all-in-one program. So the first thing that we're going to need to do is to create a private key. So you just click on this button and we'll get a seed phrase will come up. So this is going to be our seed phrase. So what you need to do is record the number sequence and also each word one by one. So there's 24 words in all. So write them all down offline in a notepad and keep it somewhere safe, and also make sure you write the words and the numbers together so you don't mix up the order or anything. If you lose this seed phrase, you will lose access to your wallet. So what happens is it's stored temporarily on your computer. Each time you open up your wallet, it will automatically load this wallet phrase for you. But if your wallet gets corrupted or something like that, you will have to re-enter this seed phrase to recover your wallet. So please write it down safely, record it, and keep it safe for future use if you need to. So once we've written that down, we click on next. Okay, so it will take a few minutes, but then your wallet will open up and it will look a little something like this. So we've got this full node status, and we've got the status here is not synced. So what will happen is it will connect to other peers on the network, and it will start syncing all of the blocks that have come up until this point. The good thing about this is that we can actually start plotting right away. We don't need to wait for the wallet to sync before we can start plotting. So we can continue on with that now. So if you go to wallets, here you can see your balance in XCH, which is the Chia token itself. You can send and receive. Obviously you got your receiving address there. At the moment, you don't obviously have any balance because you haven't found any blocks. So let's move on to the plotting process. So we've got the first option, which is to add a plot, or you can add a plot directory and see your previous plots if you have any. So we click on add plot. So we have choose a plot size. So with Chia and the current mainnet as it is, the plot sizes are actually quite big. So the minimum size is 101, and these are gigabytes, not gigabytes. I'll talk a little bit more about the size difference in a moment. And you also need some temporary space of 332 gigabytes. So what actually happens is the plot size itself ends up around about 106 gigabytes, and the temporary space is from memory about 355 gigabytes. I'll show you how you can convert those in just a moment. So there's no smaller options than that. These are the... Oh, actually, I was just saying there's... No, yeah, sorry, I am right. So this K25, don't use that one. You have to use this K32 and above. That K25 shouldn't be on there. I think they only use that as part of their testnet. So you have to use this K32. So over 100 gigabytes and 350 gigabytes of temporary space. So use that first plot to get started. So choosing your plots, just for simplicity, just start off with your first plot. So plot count of just 1. And then you've got add to plot queue. So leave that as it is as well. Plotting in parallel basically means exactly what it says. So you can plot certain drives in parallel, but for simplicity, we're just going to use the queuing system. The problem with plotting in parallel is that you're basically going to use a lot of resources. So you're going to need, for every additional plot that you add to your plotting sequence, you're going to use twice as much temporary storage, also twice as much RAM, and also twice as much CPU. So it can kind of get out of hand quite quickly, particularly on a temporary storage basis, because that does use up a lot of resources. If we just hit the drop down for the advanced options, so if we're going with just a standard single plot in the normal mode, we'll use 4608. I think the technical term is it millibytes? I don't know. Let's just call it 4 gigs of RAM, and we're going to be using 2 CPU threads. So this is like the default basis for plotting. So from here, you would probably just leave that as it is. You can increase the number of CPU threads, increase the number of RAM. From my testing experience, it doesn't really make that much difference to the overall plotting speed. It's going to be hours and hours, by the way. From my testing, if you use a NVMe drive or SSD, it's going to be between 6.5 to 7.5 hours. That's as fast as you're probably going to get it for just a single, just over 100 gigabyte plot. If you're using mechanical drives, then the time for creating those plots goes up significantly. You'll be looking at sort of like 12 hours, something like that. So just to go back through it again. So we choose our plot size, plot count, add to queue, your system settings, so how much RAM you're going to use, and also the number of threads. Buckets, you can just leave it as it is. And the queue name is just if you do want to differentiate the queuing order of your plots as you go through. For example, you might have plot 1, plot 2, etc. Disable bit fill plotting, just leave that as it is. I can't remember the difference, but as it is currently the fastest option, so that's what you want. So then we have selecting the temporary directory. So this is what is the temporary directory for building your plots. So what happens is, to avoid anyone cheating the system and creating massive plots without any real kind of work or producing them on the fly, there's kind of like a proof of work process that gets done before your plot is written. So this is a really heavy read-write operation. So although the temporary space at the top there is 332 gigabytes, the writing, someone mentioned it actually takes about 1.5 TB to be written before that plot is ready to be written to the final sort of destination. So this is a really intensive process, particularly if you're going to be using like an NVMe or SSD. It can be quite, I don't want to say destructive, but it can put a lot of wear on your SSDs. So I'll talk a little bit more about looking after those and etc. in a moment. So what you want to do is choose your temporary location. So I'm just going to choose this. You can choose different files. So your temporary location and your final destination for your plots, they can be on different drives. So don't worry about, or you can even have them on the same drive as well. So if I just do folder, and we'll just call this try attempt. So here all our temporary files get written. So like I say, there's a lots of backwards and forwards that goes on the temporary folder. But once it's written, that gets completed, and then it kind of all the information gets copied across to the final plot. So you select that, and then we want your final directory. So in this case, we're going to choose the same drive. We'll just give it a different name. Drive plot. And you can go to create plot. So the Chia temp directory gets filled up with lots of data beforehand before being written to the Chia plot. Once it's completed and written to the Chia plot, then everything in the temp location gets wiped, and you can kind of reuse it again for like a second plot. That's how the queuing system would work. So then we go to create plot. And then from here, it's going to start writing. Also, one other thing, you definitely want to change this into dark mode because it looks much cooler. So it's going to start plotting, and this process is very, very, very slow. So like I say, if you're using SSD on NVMe, it's going to take you between 6 and 7 hours. If you're using mechanical drives, it's going to take you a lot longer. I think there's some reports somewhere of up to about 20 hours, but I've only really tested on SSDs at this point in time, and then roughly about 7 hours is accurate, even with a PCIe 4 NVMe, and also like a Ryzen 9 and loads of RAM. It doesn't really make any difference. The writing speed just is what it is, and it will take you about 7 hours. If we click on the little drop down, you can view the log, and you can just see kind of like a little console readout, and from here it will tell you that the project is kind of getting started. So what you will see is this status bar will just continue to sort of fill up over time. And your drives, like I say, it's all going to be written to that temp folder. So the plotting process happens last. All of the work all carries out on the temporary folder, and in the last final sort of section, it all gets copied across, and then your plot is written. Just before I continue on to the farming process, if you are going to be using NVMe or SSD drives, like I say, there is quite a lot of wear on those drives because of the writing process. So SSDs, because they use their NAND technology, effectively they can only perform a certain amount of writes. So a lot of manufacturers will display something like a TBW value, which is total bytes written. And depending on your model of SSD, that could be a few hundred to a few thousand. So basically every time a terabyte is written, you kind of lose one of your one part of your drive for the future, effectively, or one part of wear, if you like, for the lifetime of the drive. What you can do is, if you download this, which is Crystal Disk Info, it will give you the total NAND writes and total host writes. So you want to look at total NAND writes. So this is how much data has been written to your drive over its lifetime. So you can see here it is 8.2 terabytes. So I've got obviously lots of life left on this drive, and let's have a look at the other one. So it's not even a terabyte has been written yet. So if you're looking at using SSDs, which I would recommend that you do, but just be aware of the lifetime of them. So this is a Kingston. I don't know if I can just copy that, just to see if I can find the TBW data for this drive. Just to kind of show you what I'm talking about, because it's easier that way. So normally the manufacturers will have like a spec sheet. Sorry, kind of gone off on a little tangent here, but I just wanted to show you this if it is actually available. Oh yes, here it is. So total bytes written down here. So you can see for the 480 gigabyte. So it's 200 terabytes on this particular drive. So that's actually really low. So basically I can write 200 terabytes on the drive. And after that point, the warranty is basically expired, and it's probably going to be on its way out fairly soon afterwards. So on that basis, if you go back to the Crystal Disk Mart, basically I've got another 199 terabytes of writing I can do on the drive before I'm likely to see any problems. So that's the point that I was getting at. If you're going to be using SSDs, just work out how much life you've got left on it, particularly if you're using it as your main your main host drive, because I wouldn't want any of you guys to lose any data. So that's just kind of a heads up for you. Unfortunately, it was kind of a long-winded heads up. But anyway, so once your plot has been written, you can then take a look at the farming process, which is here. And sorry, just before I go back onto that, let's go back to the plots. Just a couple of things first. If you close the Chia blockchain wallet, if your computer crashes or anything like that, or the plot gets interrupted, you basically need to delete it and just start again. There is no resuming process at the moment. So once your computer is on and started plotting, basically just leave it on to see it out. Make sure your computer doesn't do any Windows updates, goes into standby or anything like that, because you'll basically end up with a corrupt plot that you can't use and cannot resume. You'll just need to delete it. So take note of that. So the next part is the farming process. I'll switch over to a screenshot in a minute just to show you what the completed farming process looks like. But effectively, once all of your plots are written, they're going to be automatically put into this farming process, and from here you're basically going to be mining or farming. So the cool thing is, once your plots have completed, it basically automatically goes into the farming process, and then from there you'll start mining on those. I'll just show you a quick screenshot now of what it looks like when that farming area is populated. Okay guys, so I just got a screenshot here just to show you what it looks like when the plots are being populated, what they look like. So this is on another machine. So you can see I've got several plots down here, and you can see on the right hand side that they are farming, and I've got one currently still plotting. What you will see is that there is a plot seed which is different for each of the plots. There's a plot key which is different for each of the plots, but you've got this pool key, and that should be the same for each of your plots. So one other thing is that if you're going to be plotting on multiple computers, you just need to import the same wallet key for each one of those devices. And then that way all of your plots are kind of linked to the same account and the same solo pool that you're mining with. So next up we have the farm section. So let's take a look at that. So this is the farming overview and what it looks like. So you can see here we've got farming, and it's got like a little green light to indicate that we are in fact farming. Total amount farmed, currently 0 for me. I've got 7 plots at the moment, roughly totaling 700 gigabytes, so not very much at the moment. Oh, it actually says the size of the plots down in the bottom left hand corner. Size of the network, yesterday it was only like 162, so it is increasing as we go on. And this expected time to win. So this is important here, this expected time to win. So at the moment you are solo mining, not pool mining. So what that means is that until you find a block yourself, you will not have any rewards. You won't find a fraction or anything like that. You need to win a block to get the whole block reward. And when you do that, it's all kind of like a game of chance. So the more plots that you have, or the total area of plots, the bigger your chance of winning, or your chance of winning is improved, sorry. So that's also relative to the size of the network. So you can see here 700 gigabytes compared to the network size of 176 petabytes. The chance to win is once basically every 2 months. So as I increase the size of my plots, the chance to win is increased and the time will be reduced. So hopefully if you've got like a terabyte, then hopefully that should go down to about a month, something like that, which means that you're then going to be mining for a month before you find any rewards. It could take a little bit less, could take a little bit longer, but approximately a month to find a reward. So don't be surprised if you set up your plots, you're mining, and then you don't find anything for a while. So this is just a good indicator of that and something to be aware of before you get started. Okay, so just jump back to the main full node page. So up here we've got the status, and you can see now that we've started to download some blocks. We're on 320 of 53,000. So that will take, it will take probably about 12 hours to a day to get synchronized. But like I say, the good thing about it is that you can create those plots beforehand, and by the time the wallet is synchronized, your plots will probably just be finishing off, and then it will come together quite nicely for you. So one or two other little things. So the Chia network, about us, like I say, I've already mentioned that Bram Cohen is the developer of it, and he was originally created BitTorrent. So I already talked about that. They've got various help and support, but they use Keybase. I've only just got started with Keybase myself, literally in the last couple of days. Normally you would just use Discord. So this is basically like Telegram. It's probably the closest equivalent to it. So what you need to do is install Keybase. This is only for support and help and things like that. It's optional. But if you need any extra support, lots of information is within this Keybase chat. So that's probably the best resource I can give you if you need a little bit of help, get stuck or have any questions and things like that. So install Keybase and join that chat, which is this one up here. And then you'll get the best support. I'm in there as well. So I'll probably see you guys in there if you do get stuck. Okay guys, so hopefully this video has been useful to you. I'll probably do some more updates as we go on into the future. I'll talk about multiple plotting, different types of plots, the best plotting performance, and other operating systems, all kinds of things like that. But I'm trying to keep it fairly focused while I was giving you the most relevant information on this. So hopefully this has been useful. If you did like it, give it a like. If you do like this type of content and you've not seen my other videos, then subscribe to the channel, and I put out videos like this on a regular basis. And thanks very much for watching. I'll speak to you guys soon.